Good morning, folks. We are starting chapter five. And this chapter is actually going to take us home for the school year. This is going to be the last chapter we cover, which will bring us to whenever the last day of school is in this whole remote learning world. Um, Chapter five deals with all sorts of different applications of integration and using the integral. So you're going to notice that there's not so much of a fluid connection from one section to the next. Each one is kind of its own little use of integration. So integration is the big connection here in this chapter. And we're going to use all of our strategies that we did in chapter four, but in very unique ways and very unique situations and applications for chapter one. Section one, which we're going to spend several days on, deals with an economic application. So I know several of you are in AP economics already, so you probably maybe have seen some of these words and probably know the definitions, at least the textbook definitions, much better than me, but calculating them using the integration is now something you can also do. So we're going to talk about consumer surplus today. So let's get to the calculus definition of that first. And we see a very scary graph right here and some scary definitions here. Before I talk about the integral on this PowerPoint, let's talk a little bit about what consumer surplus is. It's basically a difference between what a consumer actually pays at market price for something, for either good or a service, versus the demand price of that same good or service. So a very easy example. Let's say I went to DSW and I was going to buy a new pair of shoes. And I went in there expecting to spend $100, but then I found an awesome pair on clearance that only cost $60. That difference of 40 bucks would be the consumer surplus for me. I went in willing to pay 100. I ended up actually paying 60. So I came out with a consumer surplus. So I still had to spend money. So it's not like that 40 bucks is money in my pocket, but it is a nice measurement of, we'll call it satisfaction. Okay. So knowing how to compute that is very pivotal to the economy because, again, a large consumer surplus means consumers are willing to spend more money and they're feeling better about spending the money, which always helps the economy. So how do we do that? How do we calculate consumer surplus? So we do need a demand function, which is kind of what we would expect to pay. So that's going to be d of x. All right, so this curve is the demand function. That would represent the $100 I would think to pay. And what we're actually doing now is integrating that from 0 to however many units I want to purchase. So in this case, it was 0 to 1 because I only bought one pair of shoes. Now, the demand function is often decreasing because if I bought 2 pairs, 3 pairs, 4 pairs of shoes, I would, as a consumer, expect the price per unit to go down. If you're going to spend more or on more items, you would probably want to spend less money per item in the long run. And then the last part of this surplus equation is you subtract the actual amount that you spent. So Q is the quantity, however many I choose to purchase, and P would be the price that I actually spent per item. So I integrate the expected function and then I subtract the actual price that I spent times the total number I spent. Let's see a tangible example of this. So I have a demand function, very simple, x minus 5 squared, which is decreasing up to a certain point. So I'm going to say I buy a quantity of 3 particular units of whatever this demand function is for. So the first thing I want to do is figure out what the demand would be for 3. So I plug that into my function and I get out 4. So that ordered pair that we saw here, that QP, all right, here, that would be now 3 comma 4. So now 3 times 4 would be 12. So I'm still going to integrate, but whatever I get from my integral, I'm then going to subtract 12. Okay? So we're integrating my demand function from 0 to 3, and then I'm going to subtract the number of units times the price per unit at that number. This integral is going to be something that we've seen before. It's going to be a type of function that we can integrate. All right, so this one, I would certainly want to expand it. It's only a quadratic, so it's quickly done, and we integrate. So everything is a power term, so we can increase and divide by the new powers. Plug in the 3, plug in the 0. Again, notice those two quantities are my upper and lower limits of integration. I'm still going to subtract the 12 when all is said and done, and I get a final positive consumer surplus of $27. So whatever this was that I expected to buy 3 of and pay a price for, I end up paying $27 less than what I expected, which is awesome. That means I spent less money than I anticipated. Let's see another quick example here. So this time my demand function is x squared minus 6x plus 16. I'm only going to buy one item this time. So x equals 1. So this time, again, the first thing you want to do is the actual amount that we had to spend. So plug the value for x into your demand function. I'm going to get out 11. So I spent one item at a price of 11. And now I'm going to integrate my demand function from 0 to 1 and then subtract the $11 that I spent. So that's what we see set up here. And again, we just navigate integration as we would normally. So again, it's a pretty straightforward quadratic equation. You're going to integrate, find the antiderivative, plug in 1 and plug in 0, find the difference of those, and subtract 11. And when all is said and done, it's $2.33 or 2 1/3, which we're going to round down to the nearest penny. And that would be my consumer surplus. So this time I spent, again, $2.33 less than I anticipated. So I am in a surplus. Okay, we're going to end it there. We're going to spend at least 1 or 2 more days on 5.1 before we talk about any sort of assessment. I did post some homework, so get started on it. However, some of the problems you might not be able to navigate until tomorrow's lesson. So good luck. Reach out with any questions.